So the problems will solve problems on the friction. First we'll solve the problems on the blocks on horizontal plane. Okay. Blocks on the horizontal plane. So let us write down the problem what they have given. A body of weight 1000 Newton. A body of weight 1000 Newton is placed on a rough horizontal plane. Is placed on a rough horizontal plane. Determine the coefficient of friction. Determine the coefficient of friction due to a force of 600 Newton. Due to a force of 600 Newton in horizontal direction. In horizontal direction, just to cause the body to slide. Just to cause body to slide. Okay. So first let us draw the sketch and write whatever data is given. There is a block. Okay. Okay, and they have given the weight W is equal to 1000 Newton, and they have given force of 600 Newton, and frictional force we know, we have discussed last class, that is F equal to mu R. Okay, this equation you have to remember, and there will be reaction from the surface on which it is resting. So this is what we have done. We have drawn the free body diagram of the body. Okay, and this is the direction, that is motion trend. Force is applied towards right. This is the motion trend. So R is the normal reaction, F is the frictional force. Okay, and mu is the coefficient of friction. We know mu is the coefficient of friction. Okay, then this equation is very important. Always we have to remember this equation while solving the friction problem, that is mu equal to F upon R. Okay, this is very important. Then what we have to do is, again we have to apply the equations of equilibrium, that is resolving forces vertically. Resolving forces vertically. Here important is drawing the free body diagram. Once you draw this free body diagram, then it is again simple. Okay, so upward force, that is normal reaction, and downwards it is 1000. Self weight is equal to 0, so R equal to 1000 Newton. Okay, let this be equation 2. Next, resolving forces horizontally. Resolving forces horizontally, that is sigma h equal to 0. Horizontal forces means, first there is a applied force of how much? 600 towards right, so it is plus 600, and this frictional force, this one, it is towards left, so minus F equal to 0. Therefore we are getting F equal to 600 Newton. Let this be equation 3. So what they have asked us, they have asked in the question to find mu, that is coefficient of friction mu. Okay, so from equation 1, 2 and 3, how to solve this? Mu equal to F upon R. So coefficient of friction, mu equal to F by R. F by R, that is F is 600 and R is 1000. So you are getting mu equal to
0.6.
0.6. Okay. So this is a very simple problem to begin. So they can ask you to find the coefficient of friction like this. Then next, here the force given was horizontal, right? Horizontal to the plane. Second, what they can do is they can also ask you a problem like this, that a body which is weighing 100 Newton is placed on rough horizontal plane, is pulled by a force. It is pulled by a force of 30 Newton and it is inclined. This is the change. It is inclined force. Previous problem it was horizontal like this. Here it is inclined at 15 degrees with the horizontal. With horizontal. Again they have asked us to find the coefficient of friction. Okay, so let us just draw the free body diagram directly. So free body diagram, there is a block. Okay, block is weighing how much? It is weighing 100 Newton. And there is an inclined force that is 30 Newton making an angle of 15 degrees. Okay, so there will be a reaction R from the plane on which it is resting and there will be frictional force F. Okay, and this is the motion trend. It is pulled in this direction. Now what we have to do again, first we have to resolve the forces vertically. Resolving forces vertically, first there is a downward self weight that is minus 100, upwards R plus R, and we have to find the components of the inclined force. 30 Newton, it is 30 cos 15 and it is 30 sin 15, right, for this inclined force. So taking summation of vertical forces, what we get here, plus 30 sin 15 equal to 0. So we get R equal to, on simplification, plus 100 minus 30 sin 15, 92.24 Newton. Then first we have to write this equation, mu equal to F by R. Okay, let this be equation 1, this is equation 2. Then resolving forces horizontally. What are the horizontal forces? Frictional force. This is towards negative. So minus F. One more horizontal force is this one, 30 cos 15. So plus 30 cos 15 equal to 0. So F equal to 30 cos 15. This is equation 3. Now again mu equal to F by R. So what is F? F, how much we are getting? F equal to 30 cos 15 means we will get 28.9898 Newton. So mu equal to, substitute, that is 28.98 divided by R, that is 92.24. So how much we get? 28.98 divided by 92.24, I get a 0.3 314. So they can ask problem like this. Then one more type they can ask that when there are two blocks. Okay. In the question paper, model question paper, they have asked find the force P. Just required to slide the block B in the arrangement shown in sketch. In the arrangement shown in sketch. Okay. Find also tension in the string. Find also the tension in the string. Okay. So the sketch given here is there are two blocks given at bottom. This is block B. On top of this there is a block, one more block is there, that is block A, and here there is a string and it is at an angle of 30 degrees. They have asked to find the force P, just required to slide block B. Okay. So block B, it tends to move left because here it is pulled, right? So block B tends to move left due to P, and block A tends to move towards right with respect to block B, right? First we should understand that block B, it tends to move left because of force P, and the block A, it tends to move towards the right with respect to the block B because there is a string attached. Okay. So let us say T is the tension in the string. First we have to understand this motion trend. Okay. Now let us draw the free body diagram of block A first. That is the top block. Once we draw the free body diagram, then we can simplify it. This is block A. Okay. Weight is given, that is for block A the weight is 500 Newton and block B weight is 1000 Newton, and mu is given as 0.2 for all the contact surfaces. So block A weight is 500 Newton. Then here there is a string, that is T. We have assumed the tension in the string to be T. It is acting at an angle of 30 degrees. And the normal reaction, let it be say R1, and the frictional force, we have to write frictional force, that is F equal to mu into R1. Mu is given as 0.2 R1. Okay. Then simple, once we draw the free body diagram, it is very simple. Okay. We have to resolve the forces vertically. Sigma V equal to 0, upwards plus R1, and tension in the string also we have to resolve. The vertical component of this tension in the string will be plus T sine 30, right? And one more what I have to get, that is minus 500, that is self weight of the block. Okay, this is equal to 0. Let this be equation 1. Next, resolving the forces horizontally, sigma h equal to 0. First, you have this frictional force, that is minus 0.2 R1, okay, and plus T cos 30, okay, is equal to 0. Then let us simplify this equation. 0.2 R1 equal to T cos 30, R1 equal to T cos 30 divided by zero point 0.2, which is equal to cos 30 divided by zero point 0.2 is 4.33 times T. Let this be equation 2. So substituting equation 2 in 1. Substituting equation 2 in equation 1, that is R1 is 4.33 times T plus T sine 30 minus 500 equal to 0. Therefore, how much we get? T is equal to 103.52 Newton. Let it be equation 3. Once you get tension in the string, substitute in equation 2. Substituting equation 3 in equation 2. Simple, that is R1 equal to 4.33 into 103.52, R1 equal to 448.24 Newton. Let it be equation 4. Next, what we have to do, we have considered free body diagram of block A. Next, let us consider the free body diagram of block B. So, let us draw the free body diagram of block B. So this is block A and now block B. So what are the forces we have to see? That is, the force P is acting and they have asked us to find the force P just to for the sliding. In the block A free body diagram we have got the R1 and T values. Okay. Now if we consider the block B, let me just draw the free body diagram. This is block B. Its self weight is given 1000 Newton and there will be R1, okay, because of the top block, that is block A. R1 we have already found out it as 448.24 and the frictional force, that is there will be friction between block A and block B, that is 0.2 R1. Okay, and we have already discussed that it will be moving towards this side. Motion trend is there is disturbance too much. Uh, okay, so motion trend is like this, and there is a force P. This is unknown. We have to find. Okay, and at bottom 0.2 R2. This is the R2 value, that is R2 reaction. Okay, so this is free body diagram. From the ground surface there will be normal reaction R2, the self weight of the block 1000 Newton, and R1 is from the block above, block A, and the frictional force between block A and block B is 0.2 R1, and between the ground and this block B is 0.2 R2. Okay, now resolving the forces vertically, minus 448.24, then minus 1000 and plus R2 equal to 0. So R2 equal to 1448.24 Newton. Let this be equation 5. Next, resolving forces horizontally. First, P is towards negative x, so minus P. Then this is plus, both are plus, so plus 0.2 R1 plus 0.2 R2. So these are the only three horizontal forces we are getting, equal to 0. Then minus P plus 0.2 into R1 448.24 plus 0.2 R2 is 1448.24 equal to 0. Therefore, P equal to, this is the unknown they have asked. So P equal to 379.30 Newton.